function of? Y is a function of? Most certainly. What is the function of x that differentiates to itself? Now, we all know if you had a good calculus one professor, if you had a decent, why would you use the x? You could also have all kinds of differential. Here's another one. The second derivative minus the first derivative minus 6 times y equals 0. Oh, how would you check this? Well, let's see. What is dy by dx? Let's verify it. Y is e to the x. What is dy by dx? E to the x. But what is e to the x? Verify. Now we're looking for a function. When you differentiate it twice, and then you subtract its derivative, and then you subtract 6 times it, you will get 0. Anybody know what that function is? Wow. So who are the mathematicians here? Who's going to take differential equations? Are you going to take differential equations? Look at how to solve these equations. There's a lot of tricks. Remember, what you want to do is, I'll show you how to solve this one. This one is easy to solve. Of course, you can give it to your calculus one friend. There's nothing to do here, right? E to the x. Here, you can check me. There are two solutions. One is e to the 2x. You don't believe me? I should verify it. Let's verify it. So how do I verify it? I have to differentiate this how many times?
Twice.
I have to differentiate it twice. I have to differentiate it once. Differentiate it twice. Subtract the derivative once, and then subtract 6 times. Okay. So what is the first derivative? Huh? 2 e to the 2x. And what is the second derivative? 4 e to the 4x. I'm sorry, 4 e to the 2x. Okay, so now we come in here. What do I put here? 4 e to the 2x minus 2 e to the 2x minus, and then I do what? I say 4 bananas minus 2 bananas minus 6 bananas is 0 bananas. That's not right, is it? Oh, no, it's e to the 3x, I'm sorry. E to the 3x. Derivative is 3 e to the 3x. Second derivative, 9 e to the 3x. So, 9 e to the 3x minus 3 e to the 3x minus 6 e to the 3x. 9 minus 3 minus 6, 0. The question is, how do I know that the solution is y equal to e to the 3x? How do I know that? If you take differential equations, they will show you how to solve it. But solving these things are very, very hard. Very, very, very hard. Why do we solve differential equations?
So you get to feel really good when you do it. It's really fun.
The question is, where do these things come from? Yeah. They come from laws of nature. The laws of nature, nobody tells you what the law of nature is. They say, oh, you want to know how the sun is revolving around the earth? They don't tell you the function. tell you the laws. The laws are given by how things change. And how things accelerate. Somebody tells you force is mass and acceleration. So they'll tell you, well, force, they'll tell you what kind of force they're applying on something. So, applying the force on this thing. 10 newtons. And they want to know what, Mr. Best? What is the particle? Where is this thing? We are applying the force of this. 10 newtons per second. Where is the particle? Better. You'll say there's a force on this thing. Everybody see the force on this thing? The earth is pulling it. The force is constant. And everybody knows. But I want to know, where is this particle? That one's easy. The constant force. Something like -8 or something, -10. Mass, let's say the mass is what? What is the acceleration? The second derivative of the? The derivative of the velocity is the acceleration. And what is the velocity? Huh?
Position.
Sorry?
Position.
What is the velocity?
Velocity.
Yes.
Distance over time.
What is the velocity?
First
Using calculus.
Derivative of position.
Okay, so the velocity is the derivative of the position. And the acceleration will be the derivative of the velocity. That is to say, the acceleration is the second derivative of the position. What is the acceleration? So the mass times the acceleration will be constant. 10 newtons. Give me a constant force. Give me a constant force. I give 5. Okay. The force acting on this body. Now instead of, let's say the mass is what? 1. Now what is this? Ms. Yasmina? What is this? This is a differential equation. It may look like it's harmless. Your college algebra friends, you know that's just a letter A. But we know it's the second derivative of the position. Huh? The second derivative of the position is 5. And I want to know, where is it? So I have to integrate the second derivative to obtain the velocity. Integrate the velocity to obtain the position. Clear? Who will tell me what is the velocity? What is the integral of this?
5
Huh?
5t.
5? Close but no cigar. Yes. 5?
T.
Close but no cigar.
Plus the constant.
Oh, constant. They are both following the same law, but they will have different positions. Clear? They are both following the same law. They will have different positions. velocity is 5 times c. Now, how do you obtain the position? Well, I have to integrate the velocity, huh? Plus? Huh?
2C.
Huh?
CT.
2CT. This was 10 and 10t.
Oh.
This was 8 and 8t. Plus? Huh? D. Ah, well.
It's not the same.
It can't be the same. Now, where are those constants coming from? So this is a differential equation. Okay, there it is. Where it came from? The laws of physics. Mass times acceleration. And the most important law in physics is this one here. Force produces an acceleration. The heavier you are, the less the acceleration. This is a differential equation. Because this is what? The second derivative of the position. Now, what are these constants mean?
Your starting velocity, your starting position.
Correct. So, what you have to say is, well, certainly these two are going to behave very differently. And these may behave differently, behave the same, except if I give this one initial velocity.